This is Math 2, 4.1b notes. That's Unit 4, Lesson 1b. The title is Midsegment of Triangles. So we're going to be finding a midsegment for different triangles and figuring out what the properties are and so forth. Okay, so these two triangles are supposed to be the same size, ABC, ABC. Do the best you can to make them look the same. So if I were to find the midsegment, on another day we're actually going to mathematically find it using points and distance formulas and midpoint formulas and slope and everything else. Okay, so pretend you are measuring and you cut AB in half. I'm going to call that point D. If D cut AB in half, then AD is congruent to DB. Midsegment, we've talked about that before. Okay, so let's say we took AC and cut it in half. Again, we're actually going to be doing this mathematically in another day or two, and we're going to call that point E. And I'm going to connect D to E the best I can. Now, if E is the midpoint of BC, that means that BE is congruent to EC. All right, so a midsegment cuts each side in half. So these two segments are congruent. These two segments are congruent. They are not necessarily congruent across. Got that? So these two are not, those two are not. They're just congruent on the same sides, So if we draw a triangle and we are either told that this is the midsegment, either it'll say DE is the midsegment, or we're given those tick marks, which also means it is the midsegment. There are things that we will be able to do. All right, so let's put a little note here. DE is the midsegment. Okay, so I'm going to put D, E again. BD is congruent to DA. BE is congruent to EC. So if DE is the midsegment, then DE will always be parallel to AC. The midsegment will always be parallel to the base side every single time. If DE is the midsegment, meaning those are congruent and those are congruent, these two lines will always be parallel. All right, so let's write that down. What would we say? DE is parallel to AC. DE is parallel to AC. All right, what else is going to be true every single time? Double the midsegment will always equal the length of your base. So double the midsegment will always equal the length of your base. Double the midsegment will always equal double the midsegment will always equal the base. We're going to use that all unit long, and you'll need it for the final as well. So make sure you know these two properties will always hold true. So let's just go right into examples. And sometimes you will be given triangles. Let me show you what I'm talking about. Let's draw a nice big triangle. You'll be given triangles where you're given multiple midsegments. Let me show you. X, Y, Z. And I'm going to connect across this way. M, N, congruent, congruent, that's Y, M, and MX, as well as Y, N, and NZ. Then I'm going to flip it around this way, and can you see that I have another triangle? And if I were to find the midsegment here and connect, that's congruent, and that's congruent. Okay, so I'm going to call this letter here P, And we can draw our triangle over across this way, and that's already the mid-segment for that line. That point's already the mid-segment for this line, so then we can connect, and we have 3 mid-segments. This mid-segment is parallel to this base. If I were to flip the triangle this way, this mid-segment is parallel to this base. And if I were to flip it this way, this mid-segment is parallel to that base. So you just really need to get your eyes used to seeing these multiple lines and figuring out what to do. Okay, YZ is parallel to blank. Number 2, XZ is parallel to blank. 3, PN is parallel to blank. Sorry, parallel to blank. And let's try, we're going to do some more, but let's get these 3 out of the way. Okay, where is YZ? YZ is this one. So that would be flipped around this way. This would be the base. This base is parallel to that mid-segment, so that's MP. So let's write that down and press pause, do the other 2 on your own, and then play and see if you get them correct. Okay, XZ is here. Did I mess that one up? No. Okay, so we did YZ earlier, YZ and that one. XZ is here, and this is the base, this is the mid-segment, so that is MN. PN is the mid-segment here, so if this is the mid-segment, this is the base. So PN is parallel to XY. And if you put YX, that is perfectly fine. Okay, number 4, XM is congruent to what? Okay, where's XM? That's this piece here. Do you see the tick mark? XM is congruent to, sorry, XM is congruent to YM or MY. All right, 5 is YN is congruent to blank, and 6, XP is congruent to blank. Okay, fill it in, press pause, and then play and see if you get them correct. YN is congruent to NZ or ZN, and XP is congruent to PZ or ZP. All right, moving right along. That again is just getting your eyes used to reading these mid-segment type triangles. Next piece, we're going to solve for X. Number 1, let's draw a picture . Okay, so here they don't say that this line here is the mid-segment, but given those markings, you can conclude that it is the mid-segment. Okay, I'm going to give you that this is X and that is 28. So remember the formula that was given earlier, you double the mid-segment to equal the base. So I'm going to have 2 times X equals 28. And that's what we're going to solve. 2 times X equals 28. That's 2X equals 28. Divide both sides by 2. And X equals 14. And that's it. Let's try another one. Number 2. Again, as long as you're giving markings like that, congruent to themselves on one side, congruent to itself on the other side, then this little line here is the mid-segment. So I'm going to give you this is 15, and this is X. Now remember, you don't always double the X like we did over here. You always double the mid-segment. Which one's the mid-segment in this picture? The 15, the smaller one, smaller in size. So 2 times 15 equals X. 2 times 15 is 30. 30 equals X. There's nothing to divide or move around. X is 30. You're done with that problem. Okay, number 3. Again, I'm going to put that line there. Those markings tell you that that's the mid-segment. I'm going to give you the mid-segment is x minus 8. The base is 37. Solve for x. When you do this, you always want to double the mid-segment. This is the mid-segment, so you're going to double x minus 8 equals 37. And what you have to remember is you need to distribute the 2. 2x minus 16 equals 37. And solve. Add 16 to the other side. 2x equals 53. And divide. 2 does not go into 53 as a whole number. So as long as reduce it, it doesn't reduce. 53 over 2 is fine. Or some kids will do 26.5 or 26.5. Either way, I leave mine as fractions, but this way works as well. It's up to you how you write that answer. Okay, number 4, a little tricky, so I want to address this one because kids miss this one. I'm going to put a little note up here. This one is on the test, something like this, and kids often miss it, and I'll show you why. Okay, let's put our markings there and there, so we know that line there is the mid-segment. This top marking here is 3x, the bottom side here is 27. Solve for x. And here's what kids do. They get so caught up in this work, oh, double the mid-segment to equal the base. These numbers here, these values are not the mid-segment length nor the base. It's your side length. And look at that marking, and look at that marking. What can we say about these two sides? They are congruent. So it's a little different. You don't do any doubling here because we're working with side lengths, not the mid-segment and the base. So divide both sides by 3. X equals 9. All right, so make sure you understand the difference. Number 5, I'm going to give to you and want you working this one out. Okay, so tick marks, and I'm going to give you that this angle right in here is 40 degrees. This angle down here is x, this angle up here is y, and this angle down here is 50. Okay, now I want you to think about this one. What we're using here is the fact that these lines are parallel. It's not going to mark it for you. You just need to know that if this segment cuts this side in half and that side in half, it's the mid-segment, which means they are parallel. So I'm going to have you guys try this one on your own, knowing what we know about corresponding angles. Think of the F. There's an F here, and there's an F here. So what is X, what is Y? Try it on your own, and we'll check it together in class.